Hello everyone, welcome you all. Myself Vandana and from Sri Venkateshwara College of Engineering. Today I am going to discuss a topic called as applications of Laplace transform of periodic function. Subject maths of for AAA stream, Department of Electronics and Communication. On the topic of application of a Laplace transform of periodic function in the AAA stream. Introduction to Laplace transform of periodic function. The Laplace transform is a powerful mathematical tool used in electrical engineering to analyze a linear time invariant systems. Periodic functions are signals that repeat themselves at regular intervals. The Laplace transform of a periodic function implies that analysis of a such signals in the frequency domains. Function 1. Laplace transform of a 1 is 1 by s. For t, 1 by s square. For t square, 2 by s cube. Next, for e to the power of at is 1 by s minus a. Sin at is a by s square plus a square. Cos at, which is equals to s by s square plus a square. Definition of a Laplace transform of a periodic function. The Laplace transform of a periodic function f of t is obtained by applying the Laplace transform integral to a single period of the function. The Laplace transform of a periodic function exists if the function has the finite number of a maxima and minima in any finite intervals. The Laplace transform of a periodic function can be represented as a sum of complex exponential. Laplace transform of a periodic function if f of t is a periodic function with a period a, then L of f of t, which is equals to 1 by 1 minus e to the power of minus sa integral 0 to a e to the power of minus st of f of t into dt. Now we are going to solve our numericals. First question, find the Laplace transform of a periodic full wave rectifier. F of t is equals to e sin wt, 0 less than or equals to t, which is less than or equal to pi by w, having a period pi by w. Show that L of t is equals to ew by s square plus w square of cot h of pi s divided by 2w. L of t, which is equals to 1 by 1 minus e to the power of st, 0 to t e to the power of minus small t of f of t into dt, where t which is equals to pi. L of f of t, which is equals to 1 by 1 minus e to the power of minus s pi by w, which is integral 0 to pi by a pi by w e to the power of minus st into e sin wt into dt. Now integration of we are going to integration of e to the power of at into sin bx, which is equals to sin bx my a sin a into sin bx minus b into cos bx divided by a square plus b square. Then which is equals to e is the constant term, we are going to keep it side. E by 1 minus e to the power of s pi divided by w, which is equals to e to the power of minus st divided by minus s square plus w square into minus s sin omega t minus cos omega t of pi by w to 0. Now we are going to apply now we are going to apply limits for the value of a t. Now my e is divided by 1 minus e to the power of s pi divided by w of s square plus w square is we are going to apply a for the t value we are going to apply the upper limit as well as the lower limit. Now here my e to the power of minus s my e to the power of minus st s of sin omega w by w plus cos w pi by w, which is minus e naught of s of sin of 0 plus w of cos 0, which is equals to minus e divided by s square plus w square of e to the power of minus s pi by w of minus 1 minus w of 1 by 1 minus e to the power of s pi minus s pi by w. Now we are going to get the answer as a ew by s square plus w square of e to the power of minus s pi by w plus 1 divided by 1 minus e to the power of minus s pi by w. Now we are going to multiply our numerator as well as the denominator by e to the power of s pi by 2 pi, which implies that e w by s square plus w square. E to the power of s pi by w 2w plus e to the power of s pi by 2w minus e to the power of s pi by w divided by e to the power of s pi by 2w minus e to the power of minus s pi by 2w minus s pi by w. Now we are going to get answer as ew divided by s square plus w square of e to the power of s pi by 2 pi 2w plus e to the power of minus s pi divided by s pi sw whole divided by e to the power of minus s pi divided by 2w minus e to the power of minus s pi by 2w. Now what is the value of a cos h of x is e to the power of x plus e to the power of minus x by 2. Now we are going to get that e to the power of x plus e to the power of minus x's value is 2 cos hx. Now we are going to get a final solution as ew divided by s square plus w square of 2 cos h of s pi by 2w divided by 2 sin h of 2 pi by 2 s pi by 2w. Now we are going to get an answer as ew divided by s square plus w square of cos by sin value is cot. Now we are going to get a cot h of s pi by 2w. Now next we are going to solve a next sum, which is equals to, given that f of t which is equals to e 0 less than or t less than equals to a by 2 and e minus e which is equals to a by 2 which is less than t which is less than a, where f of b plus a is equals to f of t. Show that L of f of t is equals to e by s of tan h of as by 4. Now the function is periodic with the period is called as a t is equals to a. L of f of t is equals to 1 by 1 minus e to the power of minus st of integrals 0 to t and e to the power of minus st of f of t into dt. Now 1 by 1 minus e to the power of minus sa of integrals 0 to a. Now t value is a 0 to a e to the power of minus st of f of t into dt. Now 1 is which is equals to 1 by 1 minus e to the power of minus sa of 0 to a by 2 of e to the power of minus st into e into dt plus next integral a by 2 to a of e to the power of minus st of minus e into dt. Now here e is a constant value, we are going to keep it outside. E divided by 1 minus e to the power of minus a is of integrals 0 to a by 2 e to the power of minus st into dt minus e to the power of minus st into dt. Next e by 1 minus e to the power of minus a is of, now we are going to integrate. Integration of e to the power of minus st is e to the power of minus st divided by minus s. Next we are going to apply integrals. E by s of, we are going to take s as a common. E by s of 1 minus e to the power of minus as is of minus e to the power of minus sa divided by 2 minus e to the e naught plus e minus as minus e to the power of minus as by 2. Next e by s of into 1 by 1 minus e to the power of minus as of e to the power of minus as plus 1 minus 2 e to the power of minus as by 2, which is in the form of a minus b whole square. Now we are going to get the answer as of e by s of s into 1 by 1 minus e to the power of minus as of 1 minus e to the power of minus as by 2 whole square. Now we are going to get the answer as e to the power of e by s as a constant. Next we are going to get in the numerator we are getting that 1 a minus b whole square, such that 1 minus e to the power of minus as by 2 whole square. In denominator a square plus b, a square minus b square, which value is a plus b into a minus b. Because of that we are going to write the 1 minus e to the power of minus as by 2 into 1 plus e to the power of minus as by 2. Now we are going to get that the numerator one square as well as the denominator 1 will cancel. Now the solution will remains as a e by s of 1 minus e to the power of minus as by 2 by 1 plus e to the power of minus as by 2. Now we are going to multiply a numerator as well as a new denominator as a as by e to the power of as by 4. Now we are going to get a solution as a e by s of e to the power of as by 4 minus e to the power of minus as by 2 plus as by 4. Denominator e to the power of as by 4 plus e to the power of as by 2 plus as by 4. Next we are in the numerator we are going to get as a e by s of e to the power of as by 4 minus e to the power of minus as by 4 divided by e to the power of as by 4 plus e to the power of minus as by 4. Now we are going to get that answer as e by s of sine 2 sine h of as by 4 by 2 cos h of as by 4, which is equals to e by s of tan h of as by 4. Conclusion. The application of a Laplace transform of a periodic function in electrical engineering stream provides a systematic and effective way to analyze a complex system and signals. Laplace transform enables engineers to study the behavior of a system in the frequency domain, leading to better design, optimization and control of electrical and electronic systems. Understanding the principle and application of Laplace transform is essential for electrical engineer to tackle challenges problems in various fields of technological and innovation. Thank you everyone.